What is a non-causal system? Output of the system depends on future inputs. The response of the system is produced before the input function is applied. It is anticipatory in nature. It is not physically realizable and they do not exist generally in real time. Example, image processing problem. Examples could be y of t is equal to x of t plus 2 plus x of t. This results in a future case. Similarly, y of t is equal to x of t plus t into x of t plus 1. This also results in a future case. And y of n is going to be equal to x squared of n plus 2 into x of n plus 2. This also results in a future case, making all the three systems to be non-causal. Let us consider a problem on determining whether the system is causal or non-causal. Let us consider the first case. Y of t is going to be equal to x of 2 minus t plus x of t minus 4. Let us make the first substitution. T is equal to minus 2. Hence, when t is equal to minus 2, y of minus 2 becomes x of 2 minus of minus 2 plus x of minus 2 minus 4. This becomes y of minus 2, which is going to be equal to x of 4 plus x of minus 6. As can be seen here, this is going to be a future input, whereas this is going to be a past input shown in green. Next, let us go on to substitute t equal to 0. When t is equal to 0, y of 0 is going to be equal to x of 2 plus x of minus 4. Again, we have a future input and a past case. And the last case is t is going to be equal to 2, which is going to be y of 2 is going to be equal to x of 0 plus x of minus 2. Hence, in this case, both are dependent on only past case. Still, since we have got cases where output depends on future, we would say that the system is going to be non-causal. Let us go on for another problem where y of n is going to be equal to x of 2n. Hence, we get n is going to be equal to minus 2. At n equal to minus 2, y of minus 2 would be x of minus 4, and at n equal to 0, y of 0 would be equal to x of 0, and finally at n equal to 2, y of 2 would be equal to x of 4. That means we have got some cases of n where it depends on future values. Hence, the system is going to be non-causal because for the value of n positive, that is for n equal to 2, the output depends on future value of input. Let us now try to understand time invariant system. What are time invariant system? When the time shift or the delay, or which is a delay or an advance in an input signal, causes the same time shift in the output signal, we say that the system is time invariant. The example shown here shows a delay in the input signal. In other words, there is an input signal x of t which is going to produce a specific output y of t. This, when it is delayed by tau, it becomes x of t minus tau, and hence the output also is delayed by the same tau units, which tells us that the system is time invariant. For continuous time systems, a system is time invariant if it follows the expression transformation t into x of t minus tau is going to be equal to y of t minus tau for any value of tau. Similarly, for discrete time systems, the system is time invariant if, on similar grounds, transformation t into x of n minus k will be equal to y of n minus k for any value of k. Understanding the concept of time invariant system, let us try to apply the concept of time invariance to some simple problems. First example is y of t is going to be equal to x of t plus x of t minus 2. Here the concept is going to be delay the input by tau, similarly delay the output by tau, and see what is the expression. If the expressions are same, then we say that the system is time invariant. Let us try the first case, which is delaying the input by tau. So here we get y of t comma tau, which is the representation for delaying the input by tau, is going to be equal to x into t minus tau plus x into t minus tau minus 2. In the next case, we are again delaying the output by tau, and here the expression used is y of t minus tau, which is going to be equal to x of t minus tau plus x of t minus tau minus 2, and comparing 1 and 2, we get that they are both equal, hence the system is time invariant. Next, let us go on for another example to understand the time invariance case in a discrete example. So here the example given for us is y of n is equal to log of x of n to the base 10. By similar concept, if we delay the input by k, we get the expression as y of n comma k is going to be equal to log of x of n minus k to the base 10, and delaying the output by k, we would be getting y of n minus k is also equal to log of x of n minus k to the base 10. Since these two expressions are same, we say that the system is time invariant. What are time variant systems? These are systems which do not satisfy the expressions for time variance both in the continuous case and in the discrete case. Let us go on to see what is this particular case. Hence, the expression is going to be equal to t of x t minus tau is not equal to y of t minus tau. Similarly, t of x n minus k is not equal to y of n minus k for any value of k. Such cases we call as time variant system. Let us go on to consider some problems to analyze whether the system is time invariant or not. The first example is y of t is equal to x of t into sine 50 pi t. So here what we are supposed to consider is we need to delay the input by tau and we need to delay the output also by tau. So what has been considered here is we have represented it as y of t comma tau, which is the delay in input representation. It is going to be given by x of t into sine 50 pi t minus tau. The next case, the output is delayed by tau, so it is going to be y of t minus tau. So it is, the expression becomes x of t minus tau into sine 50 pi t minus tau. Again, here we can see that there is a tau in two places, giving these two equations are not equal. Hence, the system is time variant, which means it does not satisfy the expression for time variance. Next, let us consider another example where y of n is going to be equal to n into log x of n to the base 10. Going by similar method, delay the input by k. So what happens is the representation is y of n comma k will be equal to n into log to the base 10 x of n minus k, and when we delay the output by n minus k, we will be getting n minus k into log x of n minus k to the base 10. From the expressions, it is clear that these two are not same, hence the system is time variant. Let us take up a quiz after understanding the concepts of static and dynamic systems, causal and non-causal systems, and time invariant and time variant systems. The first problem given is identify the non-causal system. Y of t is equal to x of t plus c. The first case is present input, present output. Y of t is equal to x of t minus 1. This is again a past input. The next one is y of t is equal to x of t plus 1. This is a future input, hence this is the answer. And the last case is y of t is equal to similar to b with a constant. Still, since it depends on the past input, it is a causal system. So the answer for first problem is C. Next, let us try to identify the time invariant system. The first problem is y of n is equal to x of n plus n into x of n minus 4. By now, we know that when there is a n or a t in the expression, that will also be delayed, giving a time variance case. So this is an example of a time variance case, whereas when y of n is equal to e into x of n, this is going to be time invariant. Similarly, third and fourth are also time invariant. So the answer is 2A. So the solution for the quiz is 1C and 2a. References are Oppenheim and Haykins as usual for the subject.